All right. So, what we are looking at today is average. So what does it, and you've seen this before. I mean, this could come right up front. We're talking mean median mode. You've seen this since elementary school. So we're trying to look at it a little different way, throw a few more things in there, just to make it something, how it's going to affect us in here, different than what you've done before. So, but the weird thing about average, as it says here, average is a funny concept. Although it describes all of us, it describes none of us. None of us want to be average, but we all know what that person is, so to speak, right? And it's interesting because I'll give you an example of this. I was listening to a podcast recently, and they were talking about this idea of average. And they were talking about the U.S. military. I don't know if anybody here is planning on going to the military or not. But if you go to the military, they have very strict guidelines for how tall and how short you can be, right? Like, I could not go to the Navy. I could not go to the Navy and try to be in a submarine. There's a height requirement, and I'm too tall, right? They basically say our subs are designed for people that are between this height and this height, and if you're not in that window, you can't be in the U.S. Navy and be a submarine person. That's just the way it is, right? They have the same thing for fighter pilots. I could not go to the Air Force and be a pilot in like a fighter jet. I'm too tall. They're not designed for people as tall as I am. Just like Toyotas are not designed for somebody as tall as me. I can't even fit like a Camry because my knees are like in my chest because they're not designed for a person as tall as I am. They don't even try, right? So the story was about when they first started the U.S. Air Force. So this is like pre-World War I, beginning of World War I. They were trying to say, okay, we need to design a new aircraft. And they wondered, what is our average pilot like? So they took all the people that were in the Air Force, that were pilots at that point, and they went through and they measured them. And they measured how tall they were, how wide their shoulders were, how wide their hips were, how long their arms were. And they got the average of all their pilots and said, okay, these are the best people we have. This is the average. So they designed all of their planes for that average. That's why if you're 6'5", you couldn't be a fighter pilot because you were too tall. So going into World War II, they realized they were struggling to find enough pilots that fit all of those numbers for average. So they hired some mathematician from Harvard to go through all the data of all of the officers and said, hey, go through all the military, see if you can find whoever matches this data so we can try to train them to be pilots because we need those people that are the average size. Does that kind of make sense? So he went down and looked at all of the data. He could not find a single person in the United States military that was average. Nobody. Nobody was the height. Nobody had the right shoulder width. Nobody had the right arm length. That was dead on all of the average numbers. So the idea is like it says here, it describes all of us, but it described nobody that was exactly average in all those measurements. So as we talk about average, we have to understand that when we talk about that it is. It describes everybody because it throws everybody in together, but nobody is like right on whatever those average numbers may be. Okay? All right, so the first average we want to talk about is the mean. Now these are not in your notes as listed like this. They are just spelled out as we go through the notes here. So the first one we're going to look at is the mean. How do you find the mean? Add them all up and divide. Now, depending on where you have been to this point of your mathematical journey, you may know, you may not. We need a math symbol that means add them all up. And the symbol we're going to use in here a lot is, let me go back first, is sigma. How many of you have seen this? I know you've seen it in pre-calc. You see it in Algebra 2? You had Algebra 2? Some? Okay. So sigma is the Greek letter right here, a capital E kind of looking thing. And this is a mathematical symbol that just means add everything up. So when we want to find the mean, we're going to add everything up and then divide by the number. So that is a symbol that means add everything up, divide by the number. Now, we have two means though. Think of our last quiz. If I had the mean of a sample versus the mean of a population, how would those be different? The mean of a population would be called a what? Also starts with P? Parameter. A parameter. The mean of a sample would be called a statistic. So we have different ways of labeling those two things. So, now on your notes there's the two equal signs there on the left. So the sample mean, that's the first one in your notes, we use X bar to represent the sample mean. We use mu to represent the population mean. Mu is, once again, Greek lowercase letter here. And we use a lot of Greek lowercase letters in statistics to represent population parameters, things that don't change. So mu. And if you want to write it, basically it looks like a U with a little tail on the front, right? Is mu. So X bar is sigma X, which is you add up all of the X's and then you divide by n. Lowercase n represents the number in a sample. Capital N is we're going to use to represent the number in a population. We very, very, very rarely calculate mu, because you need to add up all of the values in the entire population. So if you're trying to find the mean height of men in the United States, it's really hard to add them all up, because you don't even know all of them, right, in the population. So a lot of what we'll do here later in this class is use a sample mean, X bar, to predict or determine mu, because we can't just add up every person in the United States. It's not something easy. Okay. All right. So, find the fat content in grams of one serving of 11 grams of cereal bars, given as follows. Is this an X bar or is this a mu? X bar, it's a sample. So, if you have your calculator, we're going to do this one real quick. You can use your phone calculator. All I need you to do is add these up, divide by the number. So I have an answer here as we go forward to talk about. So you guys should all know how to find them, all right? Add them up, divide by the number. Like I said, we've been doing this for a long time. If you get an answer, check with the person sitting next to you, see if they got the same answer. Make sure you got it typed in right. What do you guys get? 8.63. 8.6. Okay. So, with this is how we're going to do this. When we round, we always round to one more decimal place than the data. So here, we have one decimal place. So we just round to two decimal places. Okay. And it's possible when you do data, and you round to one decimal place, your mean does not have to be a data value. So for example, let's say, I'm just going to make up numbers. I don't know what this will work out to be, but let's say, oh, who has a calculator there? Somebody have a calculator right in front of them? Okay, type this in for me. Sydney's got it right there. So let's go 18, Sydney, plus 17, plus 22, and divide by 3. What's our x bar?
Divided by what?
3.
19.
Even?
Yes.
Bad example. Change this to 23. Divide by 3.
19.3.
There we go. I wanted a decimal. Thank you. Okay. Otherwise, that choice to make work out easy. So, our average is 19.3. Is there any class at the high school that has 19.3 students? No. So does that mean that we round this to like 19 or 20 or something like that? No. It's okay to have a decimal point. Even if what you're using as your real data, even if it's not possible to get a decimal point. Even if you have, in this case, discrete data that has no decimal points, it's okay for your mean to have a decimal point, even if that can't possibly happen in the real world. Does that make sense? So that's okay when we do that. Okay. All right. Second one, the median. This is the symbol we use for the median. X with the little squiggly mark on top. I'm not sure what the technical name of that. Tilde? Tilde? I don't know. I was going to tilde. That's what I was going to say. I usually, technically it's called tilde. I just say X squiggly. It sounds easier for me. Okay. So instead of X bar, it's X the squiggly on top. Okay. And that's the median. And what's the median represent? It's just the middle. Okay. You write them in order. It's the middle. So now there's this really complicated sounding formula stuff here in your notes. I'm going to skip that because I think you know this already. They just made it sound really hard. So let's look at an example. So, number of tornadoes occurring in the U.S. over 8 years. Find the median. First off, to find the median, you have to write them in order, right? That's step one. So here, there are 8 numbers. So the middle would be there. From your experience, what do you do when you divide it between 2 numbers? Take the average. So X squiggly line would be 764 plus 856 over 2. You add those up, divide by 2. Somebody find that? 810. So my median is 810. If we have an odd number of numbers, and our middle number is just right here, there, our median is 12. You knew that already, right? You have done that before. And that is all, that's all this is saying. If you have an odd number, then the median is the data value in the n plus 1 over 2 spot. If you have an even number, then the value is the mean of the n over 2 and the n over 2. All that means is what we just did. Doesn't that make it sound really complicated of what you're trying to do? In reality, all you're doing is, if you can divide it in the middle, you got to take the mean of those 2. If it's an odd, it's just your middle one. So they just made it sound a lot harder than it has to be with that. Okay. Now, it's in your notes there. Another slide up here. The median is not affected by large values. Okay. So what that means is this. Let's say we take a test in here. And let's say that our median value is at 80. And let's say somebody got an 80. Matt got an 80. He's in the middle. Okay. And let's say Andrew got a 91. Let's say Morgan didn't do as well. She got a 61. Okay. Okay. So let's say after we take that test, I find out that even though Morgan got a 61, she cheated. So she goes to a 0. Does that change? Yeah, you cheated, you still failed. Does that change the median? Does the median change? No, because it's just you're dividing them in half. So having an extreme low value Or let's say that this person got extra credit and got 105 as the highest grade. That doesn't change the median, right? Extreme highs, extreme lows don't affect it. Would this, if this was not, let's say it was X bar and it was the mean, and this went to a 0, would that change the mean?
Yes.
A lot. So that was what that means. The median is not affected by large or small data value changes. The mean is very affected by that. I know when I look at class averages, I always have, or after a test or quizzes, I always kind of see, okay, what was the class average? I always look at the median. I don't look at the straight mean. Because if you have one student that does really badly, they can pull down the whole class average, and it makes the class look really low when it's not that low. So the median, I think, gives me a better reflection of where the average is, where the middle is when we look at something. Okay? Now, mean, median, our third one is the mode. Okay? And the mode is whatever occurs most frequently in the data. Many times when we use mode, it is with qualitative data, categorical data, nominal, ordinal data, we use the mode. If we wrote down everybody's hair color and said, well, what's the average? You know, brown plus blonde plus black and divide by 3. Makes no sense. That does work with the mode, that's much more useful. So many times the mean and the median are with quantitative data. The mode is more important with qualitative data. Now, you can still do the mode when you have numbers. There, my mode would be 6. What about there? What would be the mode? Is there a mode? No, okay? Now this is where it gets kind of a slippery slope on what the answer is here. What if I said that? What's the mode now? 9. 9 and 7. 2.
9, 7, 2, 3, and 4.
At what point did we cross over from being multimodal, having multiple modes, to having no mode? Is it when all of them? I mean, what if I just got rid of the 8? Is that multimodal? Or is there no mode? What about now? Do you understand like the question of when do you cross that line? And here's the great answer for you. I have no idea. There is no like definitive answer there. I've gone through all the statistic books that I have over there. Many textbooks don't even talk about it. The few textbooks that do talk about it, they have some like complicated formula that if you can't have more modes than like 25% of the total number of numbers, and it gets really complicated. I don't care at all that much since most folks don't even talk about it. We're going to say this. I am not trying to trick you. I'm not going to give you one of these and be like, haha, there was 3 modes and you said no. It's going to be pretty straightforward. You know, it will be obvious what's the mode. 9 and 7. Or even obvious, more obvious one like that, right? What's the mode? I'm not trying to trick you with this. Understand the mode just means the data point that occurs the most. Is it possible to have a multimodal thing where you can have 1, 2 modes or 3 maybe? Absolutely. Where is that line? There is no clear answer there that people have ever really defined, I think, well enough that we're going to really worry about it at all. Okay, it'll be clear. We don't do a lot with the mode. It's the least one of the 3 that we use when we use them. Now, when we talk about mean, median, mode, we also have that term average. Which one of those 3 does average mean? Technically, you could almost do with any of them, but for us, it's going to be the mean. Actually, when you take the ACT, there's some directions in the front of the ACT or the math part where it says something like a line represents a straight line. all figures are drawn in a plane. And average means arithmetic mean. Now, there is something called the geometric mean, which I don't even know if any of you have ever even heard of the geometric mean. Do you remember from pre-calc and algebra 2, what's the difference between arithmetic series and a geometric series? Arithmetic, to get your next term, you add. Geometric, to get your next one, you multiply. An arithmetic mean deals with adding them all up and dividing by the number. A geometric mean has to do with multiplying them all. It's on your homework. I'm not going to give you more than that. You can figure it out when you see it on your homework. Okay? All right. We talked about that. All right. Let's look at shapes. And I got another page of notes here. Pass out. All right, so first off, from what we talked about yesterday with our thing, we just want to talk about the shape here, not the mean, median, and mode part in the bottom. We'll come back to that. So from yesterday, we talked about how this graph here would be considered skewed right. Okay, some places will call it skewed positive. I'm just going to go with skewed right. And that is because most of the data is on the left. The tail, as we talked about yesterday, goes to the right. This graph is symmetrical. Okay, kind of right down the middle, same on both sides, right? Symmetrical. This graph is skewed left. Okay? So those are our basic shapes. Symmetrical, skewed right, skewed left. We'll talk about it again maybe tomorrow when we talk about the histograms. What if it was uniform? What do you think that would mean? They're all exactly the same height. It would be uniform. So those are kind of our big ones. Now, if we think about symmetric, we'll start with symmetric. If you have a graph that is symmetric, and it doesn't have to look like this, it could be, remember the one from yesterday where it was high on one side, high on the other, and low in the middle? You can picture that one had like two peaks. That's symmetric also. This is still true. If it is symmetric, your mean, median, and mode are all equal. Because if you think of this graph, 4 is the most common. That's the mode. Okay? This 4 divides it in half. That's the median. And then your mean, if you add these all up, would also be the same thing. So if it's symmetric, mean, median, and mode are the same. If it is skewed, think about what's going to happen. My mode would be the smallest. It would be over here at 2, right? My median would be, you divide it in half, so it would be somewhere like here, right? A little bit more. And what are these high values going to do to the mean? It's going to pull it up, right? As we talked about, extreme values affect the mean. So if it's skewed right, I will have the mode will be the smallest, then the median. The mean would be the largest because it gets pulled up with those high values. If it's skewed the other way, the opposite thing happens. The mean is pulled down. It is the lowest. Then you have the median. Then you have the mode. Okay? In that order. All right. Let's get out your calculator. If you do not have a TI calculator and you want to use one, you can jump over there and borrow one of mine. And let's go back to this data. Okay? there enough for everybody to have one? I got a few more. Okay. So here's what I want to do. We want to talk about how you can find mean, median, and mode on your calculator. Now, first off, your calculator will not find mode. Won't do it. Okay. You can do this on Excel or Google Sheets. So if you look at your notes there at the bottom, I'm not going to go back here. Do you see where? Maybe I should, so we're on the same page. Down here. Do you remember when we typed equals, average, and then you would highlight all the data? Remember doing that in one of our first lab? So you'll notice here, if you want to find the mean, you use average. This is in Google Sheets. If you want to find the median, you use median. And if you want to find the mode, you have to type mode. We'll do more of that later when we, after fair, when we come back and we'll do some labs with our M&M data and all that kind of stuff. So let's talk about how to use it on the TI calculator, okay? So we're going to go back to our data here that we started with, the front of your first, with our serial bars, okay? So first off, to put data in your calculator, this is what you're going to do. We've already worked with this a little bit. You're going to go to Stat, Edit. Now, stop for a second. I want to show you something, everybody. You put your calculators down, hands up, so you don't, you're paying attention, okay? Because at some point this is going to happen to you, and you're going to freak out, and you're not know what's going on. So, you're going to come to your calculator, and you're going to try to put your data into L1. And there's all this other data there. So you're going to go up here to L1. You're going to say, I want to delete all my data. So I click delete. And L1 is gone. And all of the data. And now, how do you get L1 back? Okay. To do this, you have to go to Stat, Setup Editor, hit Enter. It says done. Go back to Edit, and there's your list back. If you want to get rid of everything, you need to go up to L1, not hit delete, hit clear, and then it's still there. Okay? So now, let's go into L1, and let's type in those serial bars. Okay, so 6.5, 7.5, 9.5, 8, 14, 8.5, 3, 7.5. Okay. Now, if you haven't used this a lot, let me give you a few other pointers to help you figure this out. How many numbers were there in that list? 11. You can see if you go to the last number in your list, it will tell you what number you're on. Okay. Now, that's not that big of a deal when there's only 11, right? One of your homework problems has all those numbers. So you got to be, just to help you be careful that you got them all typed in. What you can do is you can look and say, okay, I got them all typed in, I'm good. Okay. Also, you may want to take a second just to make sure, just quickly scan, you didn't type in one wrong, right? Made a fat finger error, and instead of typing in 7.5, you typed in 75 or point whatever. Now, once you have that typed in, you can get out of there, second quit. You go back to Stat, and we're going to go over to Calculate one variable stats. It automatically puts in L1. For those of you with the older calculator, it should show up on your screen, right? Just hit Enter. Okay? You don't have to change it. Now, here it already puts in L1. If you want to change it, I don't know if anybody's like in chemistry, they do a lab later in the year where they got to put in a whole bunch of data in their calculator to do something. I could do this with L2 or L3 or whatever. You can't do multiple lists there. But I want to do it with L1 because that's where we typed in our data. You go down to Calculate. We'll talk about what that next thing means later. And then there is our information. If you remember from before, look what our mean was, 8.64. Right there is what we found, right? No matter how many numbers in your list, it'll add them all up and divide. It tells us right here, this is how many numbers were in the list. Okay? All of this stuff we'll talk about later. It's other stuff that we're not going to deal with right now. And if you scroll down, right here, it will tell you the median. It doesn't do the X squiggly thing. It just says median. Okay? So this is how, on your homework. Now, as I look at your homework, do I have it here? Nope, I thought I had it here. Let me open it real quick. So this question on your homework wants you to find the mean, median, and mode of those 5 numbers. Pretty simple, right? This question is more about answering these questions down here about the mean, median, and mode than finding it. However, when you go to the back, you got this set of all of these numbers to find your mean, median, and mode. So if you wanted to do that by hand, to find the mean and the median, do that on the calculator, right? But think about it. If you wanted to find the median, what would you have to do? You'd have to put them in order. So you can, and we did this before on our calculator. Do you remember how to put a list in order? We did that when we did the birthday paradox, right? If you ever want to put a list in order, that helps you find the median, but it'll also help you find the mode if you have a lot of numbers, because we'll put them in order so you can easily see where they're grouped together. The way you do that, if you remember, is you go down here to sort, L1, and then when you go back to stat, they're in order, okay? Now, that is a lot on the calculator. We are going to do a lot like this on the calculator, okay? General rule is, I don't want my calculators here to leave the room, because they don't come back. So if you don't have a calculator, you need to come down at some point to borrow it. Now, you can do all of this on Google Sheets. You can type it into an online Desmos. You can type in calculators and they can figure this stuff out for you. But we're going to do a lot with using these calculators. So one of the goals is to help you understand how to do this. So if you don't have one, borrow one from somebody else to use to know how to do this on the calculator. The better you feel with finding this stuff and sorting stuff and typing stuff in the calculator, the better you will do in this class. We use the calculator a ton, okay? So the goal, part of this, the goal is get you familiar with how to do this kind of stuff, even on ones that are fairly easy, right? All of you could easily type those into your phone calculator and find the mean. But the goal is to get you to learn how to do it on the calculator. Because other things the calculator tells you, some of these types of things, we're going to learn how to do these by hand, where these numbers come from. But long term, you don't want to do these by hand. You want to do them on the calculator, okay, going forward.